2.5 number 1, apply the remainder and factor theorems with a focus on long division. Algebra 2. Let's review long division. It's probably been a while. If I wanted to divide 86,045 by 4 without using my calculator, I would set it up like this. And we'd start with 4, take it into 8. It goes in twice, so I put the 2 up here. Then I multiply, subtract, and bring down the next number. Then I continue that process. Now I take 4 into 6. It goes in once. Then I multiply. 1 times 4 is 4. Subtract, and bring down the next number. Now I'm taking 4 into 20. 4 goes 5 times into 20. So I put the 5 up here. Multiply. 5 times 4 is 20. Subtract, and bring down the next number. Then 4 goes 1 time into 4. Multiply, subtract, bring down the next number. 4 goes 1 time into 5. And then, let's see, I ran out of space there. Let's bring it up over here. So I was left with 5. 4 times 1 is 4. Subtract. And that's my remainder. When you first learned long division, you wrote R1 for your remainder. Then you later learned, well, that really was 1 out of 4 because we're dividing by 4. So then you learned to write your answer as a fraction, 1/4. Or we could continue it as a decimal by adding zeros, and we'd end up writing it as 0.25. Now, the same process of divide, multiply, subtract, bring down the next number, divide, multiply, subtract, bring down the next number, that process is going to be the same as what we do with dividing polynomials. So if I want to divide 2x to the 4th plus x cubed minus 2x squared plus 9x plus 5 by 2x plus 1, I'm going to set it up using long division. I will put what I'm dividing into underneath the division bar. And if I skip over any terms, for example, if I didn't have an x term and I skipped from x squared just down to the 5, I would want to put a 0x in just as a place marker to help keep things lined up. Then what I'm dividing by, go on the outside here, 2x plus 1. And I'm going to start out by looking at 2x goes into 2x to the 4th how many times? I can think of this as what would I have to multiply 2x by to equal 2x to the 4th? Or if I take 2x to the 4th divided by 2x, what does that equal? Well, that just equals x to the 3rd power. So that x to the 3rd power I will put up here. Now notice, I didn't yet do anything with the 1. I want to focus on taking this first term into this first term. There's the division part. Now I'm ready to multiply. Now, I need to multiply the x cubed by the 2x and the 1. And their product is going to go down here. So 2x times x cubed is 2x to the 4th power. Then x cubed times 1 is just 1x cubed, so plus x cubed. Now remember, the process divide, multiply, and then we subtract. So I want to subtract both those terms, and sometimes to remind myself of that, I will go ahead and put the subtraction sign in, but in parentheses, or in a different color if I have it. So later if I need to go back and look, I can see, okay, that's a reminder I was actually subtracting there, and I can catch any mistakes I maybe made. So 2x to the 4th minus 2x to the 4th, well that cancels, that's 0. X cubed minus x cubed cancels as well. So I have 0, and I'm ready to bring down my next term. So let's bring down that minus 2x squared. And now I need to see how many times does 2x go into negative 2x squared. Well, a negative 2x squared divided by 2x would just equal negative x. Or again, I can think of it as negative x times 2x would equal negative 2x squared. So that minus x I'll put up here. And now I need to multiply it through to the 2x and the 1. And their product goes over here. So 2x times negative x is negative 2x squared. And negative x times 1 minus x. And now I'm ready to subtract. Now, notice I actually want to bring down my next term here as well, because I need to combine like terms. And so that 9x, I need to subtract the negative x from here. Now again, to remind myself I'm subtracting, I'm going to switch to a different color here. And when I subtract a negative, it becomes addition. So here, 2, subtract a negative becomes addition. These should always cancel. And then here I have 9x plus 1x, and we get 10x. Write the 10x down here, and bring down the next term, plus 5. Now, I want to take 2x into 10x. Well, 2x times 5 would equal 10x, so I can put a plus 5 up here. And once again, I've run out of room, so keep in mind on your paper as you continue this. Right now we have 10x plus 5. And when I multiply the 5 here to the 2x and to the 1, I get 10x plus 5. And because I'm subtracting both of those, they'll both cancel, and I'm left with a remainder of 0. So my answer of this division problem is right up here, x cubed minus x plus 5. Now, if there had been a remainder, if I got something here besides 0, I can just write it as a fraction over what I'm dividing by. So if this was, say, an 8, up here I'd put plus 8 over 2x plus 1. But there was no remainder here, so I don't need to do that. Let's practice another one. I'm going to set it up here a little higher maybe. Maybe I won't run out of room. So we have 5x to the 4th minus 3x cubed. Now notice I don't have any x squareds here. I'm going to put in plus 0x squared. So things will line up for me there. Minus 2x plus 4. Then I'm dividing by x squared minus 2. So let's start out. X squared goes into 5x to the 4th. Let's see, 5x squared times, because 5 divided by 1 is just 5. And x to the 4th divided by x squared would equal x squared. Remember, when we multiply like bases, you add the exponents, so 2 plus 2 is 4. Or if we divide like bases, x to the 4th divided by x squared, we subtract the exponents and we get x squared. Now we're ready to multiply this through. 5x squared times x squared is 5x to the 4th. 5x squared times negative 2 is minus 10x squared. And now we're ready to subtract. 5x to the 4th minus 5x to the 4th cancels as they should. Negative 3x cubed minus a negative 10x squared becomes plus 10x squared. So negative 3 plus 10 is positive 7. Oh wait, notice I have x cubed and x squared. I can't combine those. Those aren't like terms. So I'm going to erase that and move it over to my x squared column. That's better. Now, this minus 3x cubed is being added to nothing, so I can just bring it down. Minus 3x cubed. I can't overlook it. I do need to bring it down. Now I have 0x squared combining with, remember I'm subtracting here, minus a negative 10x squared, so that becomes a positive 10x squared, or plus 10x squared. And then I can bring down the next number, minus 2x. Now I want to look at taking x squared into negative 3x cubed. Well, negative 3 divided by 1 is just negative 3. X cubed divided by x squared would just equal x. And now I'm ready to multiply that through to the x squared and then minus 2. So negative 3x times x squared is negative 3x cubed. Negative 3x times negative 2 is plus 6x, and I'm not going to make the same mistake this time. I'm going to add that over here to the x column, so plus 6x. And now I'm going to subtract. This negative 3x cubed minus negative 3x cubed, that becomes plus, that cancels. 10x squared plus or minus nothing is just 10x squared. Then minus 2x plus, well, we need to subtract a positive 6x. So negative 2 minus 6 would be minus 8x. And then I'm almost off the screen here, but we still have this plus 4 that we need to bring down. And let's see, I'm going to rewrite what I have over here. So I'm down to 10x squared minus 8x plus 4. Hopefully you have more room on your paper than I do on the screen here. And now I need to take the x squared into the 10x squared. Well, 10x squared divided by x squared would just be a positive 10. So I'll put that plus 10 up here and multiply it through to the x squared minus 2. So that will be 10x squared. And then negative 2 times positive 10 is negative 20. Line that up with the other constant of 4. And now again I'm ready to subtract. 10x squared minus 10x squared, those cancel. Negative 8 plus nothing, or minus nothing, is just minus 8x. Bring that down. And then positive 4 minus the negative 20, that becomes plus 20, which gives me positive 24. Now, x squared is a higher degree than negative 8x. So I can't take x squared into 8x, or negative 8x. So what I have now is my remainder. And I can write that as a fraction. So I'm going to add to the end of this plus negative 8x plus 24 over what I'm dividing by. So my answer to this division problem is 5x squared minus 3x plus 10 plus the remainder of negative 8x plus 24. And that remainder again needs to be over what I'm dividing by of x squared minus 2. Now, if you want to check your work, the way we could check it is to take this, multiply it by what I'm dividing by, and then add back in the remainder, and it should equal the polynomial I started with. Make sure you write your complete answer, including the remainder, and there it is. You might be ready to try some on your own now, or you might want to walk with me through a couple more examples. Let's look at this one. Dividing x cubed plus 3x squared minus 7 by x squared minus x minus 2. All right, we have a trinomial. Let's see how this works. we still want to start with taking x squared into x cubed. Well, x cubed divided by x squared is just x. Now that x I need to multiply through this whole polynomial. So x times x squared is x cubed. X times x is x squared, and that's going to be minus x squared because it's a positive times negative. And then x times negative 2 minus 2x. Now, what I notice here is that I have x cubed, 3x squared, minus 7, but I don't have any x's. So let's move that minus 7 over a little bit to allow room for an x column. So because I don't have any x's, I'm going to put in plus 0x. So now this x I can line up with x's. Now I'm ready to subtract. X cubed minus x cubed, those should always cancel. 3x squared minus a negative x squared, so that becomes 4x squared. 0x minus a negative 2x becomes plus 2x. And then bring down the next number, minus 7. Now, it's these positives and negatives that usually cause people the most trouble and where most mistakes are made. So be careful when you're subtracting a negative that you're actually adding, or if you're subtracting a positive that you are subtracting. All right, ready to divide again. X squared into 4x squared, well, that would go 4 times. So I'll put the positive 4 up here, and then I need to multiply the 4 to every term in this trinomial, which would give me 4x squared minus 4x minus 8. And now I'm ready to subtract. 4x squared minus 4x squared, those cancel. 2x minus a negative is going to become plus 4x. So that's 6x. Then negative 7 minus negative 8 is going to become positive 1. Now if I look at taking x squared into 6x, I can see it's not going to go into it because I'm looking at a lesser degree here. So here's my remainder, which I can come and write as a fraction, 6x plus 1 over, when I'm dividing by, x squared minus x minus 2. And one more example if you need it. All right, 3x cubed plus 17x squared plus 21x minus 11 divided by x plus 3. So x goes into 3x squared, or 3x cubed, 3x squared times. Because 3x squared times x does equal 3x cubed. And now I can multiply and multiply again, the 3x squared times this 3, that's 9x squared. And now subtract. 17x squared minus 9x squared is 8x squared. And bring down the next term. And x into 8x squared would be 8x. So I'll put positive 8x up here. And then multiply. And subtract. 21 minus 24, negative 3x. Bring down the next number, or the next term, negative 11. And negative 3x divided by x would just be negative 3. Distribute the negative 3 to the x plus 3. We get minus 3x minus 9. And subtract, which becomes addition here, subtracting negative. Whoops, I made a mess of that. But negative 11 plus 9, that should be a plus 9 there, equals negative 2. So if you can see that, that is a remainder of negative 2, which I can write as plus negative 2 over x plus 3. Or I could even put the negative there and write minus positive 2 over x plus 3. And that is long division. In the next lesson, we will look at synthetic division. Synthetic division is faster and easier, but we're limited on when we can use it. So tune in next time for synthetic division.